Collier and Hoffler, Fearon and Leighton, and dozens of other scholars have found significant relationships between national level GDP and conflict. For a bunch of different theoretical reasons, Collier and Hoffler's focused on greed explanations, Fearon and Leighton focused on state capacity, for example. However, in recent years, academics have tried to push our knowledge beyond just state level aggregate measures of economic production and go to a more refined understanding of this relationship. In doing so, I think it highlights some challenges to causal inference, both here and in other research areas. The first challenge I want to talk to you about is endogeneity. The second is level of analysis problem. When speaking of endogenous relationships, specifically around money and conflict, Miguel et al. 2004, the second reading for today, is probably the best known. Their main points is that previous Civil War models were flawed. A lot of writers haven't fully appreciated how much economics and violence are interrelated, i.e., endogenous. Endogeneity is basically a fancy way of saying that the arrow can go the other way instead of from cause to effect, from a nominal effect to cause. Think of it like the arrow going the other way in the path diagrams that you did for last week. Or here, whether conflict can lead to greed or grievance, right? Or greed as proxy by GDP, lower GDP, whether conflict can reduce economic capacity. In Collier's later work, Breaking the Conflict Trap, that I mentioned before, during Civil War, they found that military spending increases from on average 2.8% of GDP to 5% of GDP during conflict. So you see that both conflict could have a negative effect, but it could also increase military spending that could lead to economic production to make all these equipment. The other main point that they're trying to make is that some important factors have been overlooked in existing models of conflict, or so-called omitted variables. For example, government institutional quality might affect both the economic production or the probability of violence. That would be a spurious relationship. You have a third factor really driving the causal effect that you're looking at between X and Y. A pure omitted variable bias would be something that affects conflict but doesn't really affect anything else in the model, but that it's like, for example, military intervention or involvement in a country might have an effect on the likelihood of conflict. Research that I and you and everyone else does is based on the premise that you need to extract away from the messiness of reality and try to figure out what is more or less important to understand whatever outcome we're really focused on. But this process is by necessity incomplete and potentially biased if, due to your own limits of knowledge or assumptions or background approach, it ends up leading you to not appreciate a factor that you leave out of your theoretical or empirical models. Their empirical contribution has been substantial. It's been a really influential article, is that you need to estimate the economic shocks and their relationship to conflict simultaneously. That economic shocks can increase the probability of conflict, but that there are factors that can lead to both economic shocks and conflict. So you need to model both of those things simultaneously. And in order to do so, you need to find something that isn't in both of those equations, something that's unique to one of those relationships but not the other, right? That has a plausible claim to exogeneity, something that can't be affected by either economic shocks or conflict. And that is what we would call an instrument, something that has an effect on one thing but not another. In this paper, they focus on rainfall as a possible exogenous effect on economic growth. The more rain there is in agrarian societies, the more likely you're able to grow your products and produce more, right? But that rainfall shouldn't directly lead to conflict itself. They also say that in order to control for omitted variables, you want to be able to include proxies for just those things about a particular country you can't measure, or the particular time that you're looking at those countries. So you look at it, they include country fixed effects and year fixed effects, which are basically a way of saying we know there's something about countries that we're not capturing in our models, or some effects of time. We don't know what those things are. We're just going to put in dummy variables in those and then control for those factors to be able to focus on what we really care about. Their main substantive finding is that a 5% decline in growth leads to a 12% increase in the probability of conflict in Africa. This is one thing that I want you to be able to try to get out of all your readings, that there's one thing to show that there is a significant relationship, but if it's only really tiny, that doesn't really tell us that much about the important drivers of conflict. And so this shows that there is a relatively large increase in the change in probability given that variation in economic growth. But it's less intuitive to try to look at just point percentages. That's why I think in this paper and in others, I like graphs and pictures and figures. And so you can see in this figure 2 of their model, they kind of plot that substantive effect. Did any of you really spend any time looking at this or any of the other figures in their papers in detail? Maybe, hopefully. Did it raise any red flags for those of you who did look at it? If you haven't, I would encourage you to take another look at it. We're going to look at this and the other readings in more detail in the workshop, but I want to try to highlight the fact that if you read closely and you look at the decisions that the writers make, you might be able to come up with questions that might either spark concerns or things you might want to follow on in your own research. This figure kind of annoyed me, and I just want to highlight why I'm annoyed and how you might be able to use it for your work in this semester. First, I want you to be a skeptical reader. This is an upper level class, and instead of just trying to inhale facts, I want you to be critical analyzers of specific texts. All authors have to make trade-offs. You will for your own paper as well. Some of these trade-offs are visible and some are not, unless you're really in tune about what actually matters. Second, connecting to the percentage change earlier, you want to look at the substantive effects. They argue that rainfall growth decreases conflict. They graph this relationship in the first round of models they do for table 3. The solid line looks at the predicted effect of rainfall growth on the predicted likelihood of conflict. The overall downward arc of this relationship is to be expected and is helped linked to why the coefficient is negative in table 3 for this model. But if you look closer, there's a couple of things that stand out, at least to me, right? First is the y-axis. It's the likelihood of civil conflict. The question is, how can you have a negative likelihood of something? You look at the bottom part and you have a -2 there on the y-axis. Anyone understand why that might be the case? It's because they are using a type of model that is not appropriate or not traditionally used for the outcome variable that they're using. 0, 1, is there a conflict incidence or not? OLS, ordinary least squares regression, expects the outcome to be a continuous variable like money, and so you can get nonsensical predictions if you use the wrong kind of dependent variable with it. So the main relationship in this line is actually in an area in which the probabilities cannot go in real life, right? It's weird. Second is the dotted, the dashed lines are confidence intervals. If those are crossing, or if 0 is between those two dotted lines, that relationship, the part of that relationship that includes 0, you can't tell the difference between that and 0 itself. It's not statistically significant. The fact that the top band only dips below 0 to be significant at only 2 different parts of the graph suggests that the rainfall growth only really has a significant effect on conflict in these narrow, rather high levels of rainfall growth. This makes sense, but I wonder how many values in countries there were for these observations. Are there particularly influential observations there, like with the GDP of Liechtenstein or the US in a particular model? Most predictive graphs you'll see will have confidence intervals in this paper, in this class, and so I want you to try to look at the graphs to see if any of them actually include zero. So yeah, I went into the weeds here, but I wanted to highlight that you could look at any piece of work and see choices about theory, about research design that you can discuss, raise questions about, and analyze for your literature review or for your main paper. What I think important about this paper and why people are still talking about it over 15 years later is that they highlight the importance of endogeneity and omitted variable bias, and the importance of trying to find things that are plausibly not related to either one of your factors if you want to try to control for potential endogeneity. The article has helped shape the field and it's been cited over 2,500 times. So it really has had an effect. But of course, I'm not the only one that's had a question about this article or others, given its popularity. I thought I would draw your attention to this follow-on article. There's been critiques and refinements of this rainfall as an instrument for conflict over the years. I think while it has had an effect on how people think about endogeneity, the questions about how robust the findings are and what the findings are dependent on, you can raise questions about things that people who just use data without thinking about how they're generated might miss. This article by Ken Schultz and Justin Mencken, I think, is a really clever and interesting recent example of this. They, are one of those papers that when you read it and you're like, wow, I had never thought about that. That really helps change about how I think about both the data generating process as well as about the substantive effects, right? Just, my brain is melting down. When you think about weather stations, I don't know how many of you have actually been to a weather station. They're basically gadgets to gather information about temperature, rainfall, snowfall, wind speed, those kind of things, that helps people predict short-term changes in weather and long-term changes to climate. Probably the most dramatic example that I could see of a weather station would be this one here in the Khumbu Icefall on Mount Everest. Yesterday, I checked the temperature at the South Col, which is almost 8,000 meters, and it was negative 5.7 degrees Celsius. Not that much different than what Canberra is doing right now, but it absolutely boggles my mind that you can get live information within 24 hours from one of the harshest and most remote parts of the world. These weather stations, some have been gathering information for more than 100 years, help us understand the climate and how it's changing. I think the two things to kind of take away from this photograph here is that the thing looks fragile. If I took a running start, I could probably knock that thing over. And second, you have to have people involved to both set the thing up, to monitor it, and come out and fix it if the sensors stop responding, or if something gets damaged. So these things are not completely automated and require a lot of human observation, which kind of leads to the importance of the Schultz and Mencken work, in which you just see this graph here, in which you see the relationship between the number of conflict events in an area and the number of weather stations, two different weather station sources of data, the CRU and BEST data sets. Their main point in this article is that civil conflict and the number of weather stations reporting in a country are negatively correlated. That's because conflict can directly damage stations by one side or the other blowing it up or destroying it, or if it drives away people from taking care of it and it just stops responding. The paper finds that the measurement error, due to the fact that conflict reduces the number of weather stations in an area, reduces the strength of the relationship between weather and conflict. That if you control for the measurement error and reduce it, their example is looking at changes in temperature. The effect of temperature on conflict is twice as large as previous studies have found. To try to make this a bit more visceral, just look at this graph from their paper. The paper is easily findable online. You see evolution over time in sub-Saharan Africa from 95 to 2015. Note specifically 2015, the large parts of white in which there isn't a weather station within 1,200 kilometers of it. And you see some countries like Zambia, Tanzania that really don't have any kind of weather stations. They have one other map again, looking at how maps help us show different values of the world that we care about in an easily understandable format. You can see here as well, you have a lot of gaps in the number of weather stations, which affects accuracy and extrapolation from weather stations to other parts of the country. For me, I kind of got curious looking at sub-Saharan Africa. You see these number of weather stations, what it looks like here in Australia. So I went to the Australian Bureau of Meteorology, BOM, and downloaded data on the weather stations in the New South Wales and the ECT. Took a bit of cleaning, and I got to geek out with it a little bit, but the takeaway is that there's 517 weather stations, almost as many as the entire continent of Africa in certain areas, just in New South Wales and the ACT. You see a cluster around Canberra. You definitely see more clustering along the coast than you do see farther inland. So I think it's interesting that weather stations and where they're set up can be set up for reasons different than the ways you want to be able to use your data. And I think the Schultz and Mencken piece remind me of another, how fallible a lot of research is and how much of it is an art, and you need to be kind of focused on the details. It reminds me of this recent case of an article by two Harvard academics, Reinhardt and Rogoff, who were incredibly influential in both economics as well as policymaking, in which they had their argument was that if countries' debt to GDP ratio, if countries owe a high amount of money, they're much more likely to lead to negative growth. That high debt slows growth. And this really shaped a lot of countries' responses to the economic crisis of 2008, 2009, because countries were less likely to try to borrow their way out of it because they worried about the long-term effects of having too much debt. Enter a couple of three academics from University of Massachusetts Amherst, which is definitely not Harvard. They published a paper in 2014, and they found that, to quote them, the selective exclusion of available data, coding errors, and inappropriate weighting of summary statistics led to serious miscalculations that inaccurately represent the relationship between public debt and GDP growth. The quote and the source is in the course notes. But basically, they found that Reinhardt and Rogoff had made a simple error in Microsoft Excel, leading them to use the wrong calculations that found a relationship that once you control for that mistake, basically that relationship disappears. So a Microsoft Excel error, which I'm sure I have and everyone has made, had an effect on countries' ability to spend money to help their citizens during an economic crisis. So research is made by humans. People make mistakes, and so that's why the one thing academia does well is try to be transparent so that other people can follow up with it and try to poke out the errors, and we have an iterative positive effect on our knowledge about the world. A couple of takeaways, I think, from the Miguel et al. Piece and these kind of other examples is that previous Civil War models were missing some important factors. They didn't appreciate how much economics and violence are interrelated, and how difficult it can be to find things that are exogenous to political phenomena to allow you to model things correctly. Some important factors that are overlooked: government institutional quality might affect both economic growth and violence, and how it could just be difficult to include every possible explanatory factor. So yeah, a lot going on, but we're gradually getting there to understand that more developed countries overall across a whole bunch of different models are less likely to go to conflict. There's different theoretical reasons that people have argued for why that relationship exists, and different modeling assumptions can shape how big the effect is between those two, and how much other factors also interact with it. Let's take a quick break and continue the conflict discussion before moving to human security. Here's a brief video. It's actually 19 minutes, but you don't have to watch all of it. A couple seconds will kind of give you the gist of the entire year of 2019 in weather from a collection of weather satellites around the world. Before we do take the break, I'd like you to also answer another question about the material. Lecture question 2 to respond to on Waddle. Can you think of and briefly describe an endogenous relationship between conflict and another causal factor, not economic growth, we have discussed so far? Can you think of another relationship in which you can draw the arrow going both ways? It could be something that you're interested in looking at later on, or it could just be something that you could try to make a plausible case against the conventional wisdom.